Emily?
4x cubed.
Good. Plus.
Plus
What about next?
negative 5x squared.
Good. Plus.
Negative 3x.
Good. Then who could tell me what do I get on the bottom one? Thomas? What's 2 times negative 4x squared? Yeah. What does this become? Negative 8x squared. And look at where it goes right underneath. You see? And then this becomes 10 plus 8. And just like Kobe said, look. Look at all the like terms. Didn't they line up? Isn't that great? Okay, they line up nicely this way. See what I mean? And of course, and you know how I always tell you to change everything to addition? Okay. Another nice thing about that another nice thing about that is when you do that, look at between each of these terms, you have what in between each of these terms? You have addition symbol. You see how simple that is? So every time you write this, it's always going to be addition in the middle if you change all the polynomials as addition. Right? Could you imagine if some of them was subtraction and the other ones addition and so forth? It could get kind of confusing, you see? But now everything's addition, so you don't have to worry about what operation comes between each of these terms. Does that make sense? Okay, now when we're ready to add, because we now have the like terms lined up, you could tell me what I get here when I line them up. Okay, who haven't I called? How about somebody that didn't get called? Who didn't get? Sierra? Okay, go ahead.
4x
Uh-huh.
plus negative 13x squared.
Good.
Plus 7x plus
That's right. And of course, I could use the definition of subtraction and, of course, write minus 13x squared instead of plus negative 13x squared. Any question? Does that make sense? Are we good? Okay. Good. Do you think you could do something similar as example 2 then, by yourself? Okay, go ahead and try example 3 by yourself. And do you think it's a good idea to rewrite them in standard form first? And change everything to addition while you do that? Yes? Yeah. Go ahead, everybody try. I'll give you some time. Here we go. Alright, let's go over them. I think a lot of you got it wrong. I mean, right? Not wrong. yeah, I think we got it right. Okay, so you all listen to my suggestion. Did you all write them into standard form like this? Okay, good. All right, who could tell me what to write first? Shirak, go ahead.
I got 2y times x.
No, okay, so tell me what to write. X times, so I'm going to multiply this x throughout this trinomial, right? So I get x times 3x squared plus what? Christine, you know what I'm talking about? Good. Plus.
Times xy.
Uh-huh.
Plus x times negative y.
Shirak, you know what I'm talking about? Did you do this work? Okay. Which way?
2y plus x.
Oh, see? Shouldn't you choose one variable, x and y, and then you were to write this in standard form? But it's okay. Well, then what did you get for 2y times this? What do you get?
2y times
Uh-huh. Yeah. Plus?
So I got 6x squared.
Oh, no, don't tell me what. Okay, so 2y plus 3x squared plus what? 2y times xy plus 2y times?
Negative y.
Right. Okay, now tell me what you get when you simplify. Who could tell me what I get here? Talene?
So you get 3x cubed
Uh-huh.
plus x squared y
Yes.
plus negative xy squared.
Good. Shirak, tell me what I get for the other one then. This is what you wanted to tell me, right? Okay, then this, when you multiply this, you get.
X squared y plus negative xy squared.
No, the bottom part. What's this? If you multiply 2y.
2xy squared minus 2y squared plus 6x squared y plus 6x squared y minus xy squared.
What? Wait, what are you talking about?
6x squared y plus 2xy squared
Uh-huh.
plus negative 2.
Yeah, that's what I mean. Don't you get, the bottom part, don't you get this, Shirak? Okay, what's your answer, Shirak? What'd you get? That's your final answer.
Cubed plus 7x squared y plus xy squared minus 2y.
That's right.
There you go. Okay, you got it. Okay. How many people got this? Raise your hand. Very good. Any question? Now, if you miss This, do you see where you went wrong? How many people now see where you went wrong there? Here again, how many people got it right? Raise your hand again. Good, okay. If you didn't, do you see a mistake? Because if you don't, ask me now. Okay. I have all the work up there, right? So let's change a gear and do something like this. Can you see I have 4 rectangles, A, B, C, D, and can you find the sum of the areas of the 4 smaller rectangles? Is that hard or easy? First of all, how do you find the area of a rectangle? Raise your hand if you know. John? Length times width. Okay, so they want you to find, what does sum mean? Yes, Emily? Add. What do we want to add? Raise your hand if you know. It says find the sum of the areas of the 4 smaller rectangles. What do you want to add? One person knows? Kyle, what do we want to add here? What did they want you to add? Because it says find the sum of what?
The areas of all the 4 smaller.
Yeah, areas of the smaller rectangle. Kyle, can you tell me the area of the A, the region A? What's the area region?
X squared.
X squared. It's not 2x. You multiply x times x. Oh, Cameron, did you?
You just like the whole thing as a whole instead.
Actually, hold on to that thought because you're reading my mind there. We're gonna get to that. Very good. Cameron says something. I'm gonna get to that in a minute. So yeah, so the area A is x squared. What about the second region B? Anybody know what the area of the second region is? Anais?
I got 5x.
You're right. How'd you know it was 5x?
Because the length is 5.
Yeah, width is 5, the length is, well, it doesn't say right here, but you could look at the other side. Yeah.
Yeah.
Okay, so you're right. So just because it doesn't say, you could. Okay, what about the C region? Judy?
3x.
How'd you know it was 3x? Yeah, this is 3. It doesn't say anything over here, though. How do you know the width is x? Yeah, on the top it says x. Okay, that's fine. What about D? Nelly, what's the area of D region? D. Yeah, 5 times 3. Right here is 5. Here is 3, right? It's 5 times 3. So it's 15. Yeah, I just wrote 15. Is that okay? And am I done? Madeline, what do they want you to do with these areas? Yeah, I want you to add them together. Madeline, what's the answer? Uh-huh. That's right. So you notice that we had a like terms, right? We had 5x and 3x, they're like terms. So you get x squared plus 8x plus 15. Correct? Any question? All right.
Oh, wait.
How did I get what?
X squared.
Yeah, what's 5x plus 3x? Yeah, that's why you get 8x plus.
How'd you get x squared?
Okay, the region A, the area was x squared, region B was 5x, region C was 3x, and then D was 15. Yeah, you just add them all up.
I thought you somehow got.
Oh, yeah, just add them all up. Now, hold on, I know you see, okay, but Cameron said something interesting very beginning. What did you say, Cameron?
That you just find the area of the whole entire rectangle.
Yeah, why do we have to find, like, if I add up all the areas of the small rectangles, Kobe, what's that same as?
Area of the whole.
Area of the whole rectangle. What's the length of the whole rectangle, Kobe?
X plus 3. X plus 5.
The length is this, x plus 3 is right. What about the width?
X plus 5.
X plus 5, is that right? So can we just multiply those two binomials? If I multiply those two binomials, what should I get?
X squared.
The same answer as this. So everybody go ahead and verify. This is what I should do, right? Isn't this the same as doing this? Oops, let me show you, hide the answer. Right? And when you multiply these binomials together, what should you get? Same trinomial as before, right? Go ahead, everybody multiply it out. See if we get, what was it? Yeah, see if we get x squared plus 8x plus 15. Go ahead, everybody try. And so you're exactly right. So when you multiply this binomial, we get the same exact area. Let's see if we expected. How many forgot the same area? Good? Okay. You're going to have this for your homework tonight, something like this. They're going to give you some areas, like rectangles, and they're going to ask you to add all the small areas, and then compare that with the actual total area. You should get the same exact answer. Does that make sense? So you could think of this multiplying polynomials as like areas, adding up the smaller areas versus the whole thing. Any question there? Good?